I'm really looking forward to this next presentation. It's on one of my favourite topics, which is around waste and energy and how we get the most from them. So I am delighted to introduce our next speaker, which is Dr. Kaoru Kikuyama, the Vice President to JFE Engineering Corporation from Japan. If we could just welcome her up onto the stage, thank you very much. Thank you very much for that last session. I'm delighted to welcome our next speaker, Dr. Kaoru Kikuyama, the Vice President of JFE Engineering Corporation from Japan. Thank you very much.
Well, ladies and gentlemen, good afternoon. Before I'm going to start my presentation, first I'd like to thank the organizer to give my company this precious opportunity to present in front of you. In fact, my presentation today titled as Waste for Energy and Water. So not only for water, but also I'd like to cover energy out of the waste, utilizing the waste as a resource. In fact, before I start, I'd like to share two pictures, actually. This is a Japanese mega city, Nagoya City, in 1945. Actually, the present, looks like just like this. In fact, this is one of our major commercial towns, and we have converted it to this beautiful, big mega city now. And this is Kawasaki City. And actually, this is very nearby to our office. And then presently, it looks like this. What I wanted to show you here is that those mega cities over the past years, under the huge economic pressure to develop, actually, they suffered quite a bit of environmental pollution. But over the decades, we managed to address those environmental pollution and issues. Somehow, my company, JFE Engineering Corporation, has also contributed to address that kind of issue. These are the pictures I picked up regarding the Middle East, and please do not be offended. But those wastes on the top left and the landfill on the right, and also the waterless river on the bottom, and flare gas discharged to the air, polluting the environment. And also the the bottom picture, that is contaminated water at the oil-produced field. So we think that there are lots of wastes in this particular region, but we'd like to utilize those wastes as a resource to manage the environment altogether. So here, I'd like to share with you what are wastes in a concept in my presentation. First, I'd like to say that the sludge from wastewater. Second is gas and oil produced radiated water and flare gas. And thirdly, the byproduct from life and industry. Those are in my category, they're regarded as wastes. But before going to my main presentation, just allow me to quickly walk through my company. Since many of you may not have heard JFE Engineering Corporation before, in fact, we are the holding company. And apart from JFE Engineering, we have 3 other companies with us. And our annual net sales is about $3 billion per year. And we have 7,400 people all over the world. In fact, we are the leading EPC company in Japan, and we have got the top share in the EPC field in Japan as well. Our major business field, actually not less limited to these 6 fields, we have even more, but these 6 fields are actually leading business field. I'd like to just introduce you here. Water treatment and biogas from sludge, waste to energy, and smart agriculture utilizing hydroponics, which we just launched from last summer. And also we have lots of EPC design and innovative technologies actually awarded all over the world, including those Sky Park. If you have been to Singapore, you may have noticed on the hotel, Marina Bay Sands, that is our design and construction work, which has been also awarded for the best design. And we have also energy projects. including the renewable energies, biomass, biogas, geothermal, solar, wind, and also those energy-rated facilities such as LNG tank, mega tank, we call it, also seismic resilient gas and oil pipeline, and so on. We have got offices all over the world. In fact, there are 13 offices. There is one in the Middle East, in Saudi, in a place called Al-Kabar, and our headquarters located in Yokohama and Tokyo, in 2 cities. So with this quick overview of my company, let me just go to my main part of the presentation. Well, the treatment for wastewater sludge, I'd have to say first. But before I go into it, I just wanted to share with you why we try to recycle everything in my country. Because we are a very resource-scarce country. In terms of energy, we have only 6% self-sufficiency. The rest of energy sources are imported mainly from Middle East and some other regions. Well, in case of water, we have got abundant water in Japan, actually. However, the water price is very high. We are not subsidized. So therefore, we are naturally minded to be very environmentally concerned and very how can I say, environmental conservation minded. So this is our national characteristics. With this culture background, we have at first developed the water recycle capability. In fact, those dirty water, wastewater can be recycled for irrigation or for industry purpose. This picture shows that, this chart shows that our reference case, which we introduced to the plant called Iriezaki plant in Kawasaki City. What we do, we use microorganism immobilizing carriers and anaerobic, anoxic, and aerobic process. With this system procedure, we have achieved the removal of phosphorus by 40%, and nitrogen by 30%. In fact, that the water after recycled in this, with this plant are used for paper manufacturing factory for the production line. Here is a sludge management. I heard that maybe in this country, sludge are not utilized for example, electricity generation, something like that. But in Japan, we are, as I said, we do not have enough energy resources ourselves. We try to utilize every type of waste as a resource for energy. So in terms of sludge, this is reference from our Yokohama plant, located very nearby to our office as well. In Japan, 70% of sludge are recycled for generating power and electricity. And then my company, JFE Engineering, has a top share in Japan for this. From here, I just want to go through very quickly about waste to energy project we have. This is not necessarily water related, but I just want to show you that what we do in Japan and globally. This is a typical picture of landfill. In Japan, since we have such a small land, we do not have enough space for landfill anymore. Also, because of the environmental, very conscious people, therefore we stopped landfill our garbage and waste anymore. So in fact, those wastes are actually consist of several types of waste, including medical waste or chemical wastes. In Japan, in fact, we segregate the waste into different types, non-combustible and combustible, or recyclable newspaper magazine, or steel can, glass bottle, and plastic bottle also. How we approach the waste management itself. In fact, if you can, as you can see here, for those recyclable wastes are going to a pre-treatment process, and there those recyclable wastes are going through the recycling later. But for those combustible waste out of municipal solid waste, We either incinerate or gasifying and then use it for generating electricity. In terms of organic or sewage sludge, we solidify, for example, those waste, and then either digest or those solidified waste go for as a solid waste after carbonized and used for thermal plant, such as coal-fired plant. This is one of the case, the reference, the Nagaoka biomass power plant. We actually treat 65 tons of waste per day, and then we managed to generate electricity 12,300 kilowatt hour per day with this plant. In fact, what we achieved with this is $35 million for next 15 years, reduction in cost, and also we generate 4,100 megawatt hour per year electricity. In total, we are managing 2,000 tons of CO2 per year. This is a process how we treat the waste. We collect burnable waste and food waste. And then those burnable waste go to incineration plant straight away. But those food waste are going to be sorted and then either fermented as biogas or being dehydrated to become a sludge and then become a carbonized fuel after the process. Therefore, in both ways, we can use to generate electricity in the end. Oops. Excuse me. This is the new project we have just launched. This is world first multi-biogas plant. What is multi about is that we combined food waste and sludge and human waste into one plant system. Normally those three types of waste are dealt with in a separate plant. But what we do, we combine together, therefore we can maximize the cost reduction by 20%. At the same time, CO2 reduction can be achieved 3,900 tons per day. We use those biogas after treated again for electricity purpose, or those sludge will be carbonized as a fuel to be burned in a thermal plant. In case of incineration and gasification, we have got very highly innovative technologies. We have got a gasification plant under our list. This one is very unique because in terms of gasification, you don't have to sort those waste. We can put every type of waste, including hazardous waste, into the plant, and we melt it with 1,600 degree temperature. In fact, this is a pretty high temperature, and there's only 2 companies in the world can manage this temperature gasification process, and one of them is us. We have got also incineration plant in a place called Hirano, Osaka City. This one is unique for us because we managed to integrate the data set to make a remote control, not on-site, but from off-site, and therefore we do not have to station the staff on-site. What it means that we can economize the total operation value, and also we can have a very efficient, detection system and monitoring system remotely. So those are the waste management. And here is, I'd like to share with you gas and oil produced rated water and flare gas management. I believe that those water, in fact, in especially water scarce region like Middle East, would be badly wasted after used for the pumping the oil and gas. Our proposal is to reuse it, and I'm sure that lots of people have already proposed the same idea. But what it is good about when recycling those water, we can use it for irrigation or industry purpose. In fact, we have got this oil-produced water treatment system, not only using evaporator, but also we use a reverse osmosis membrane. And in fact, after treated, we have about the desalinate water 87%, and in concentrated brine comes about 13%, which can be used either for incineration or generating electricity. With our system, in fact, we achieved low energy consumption by 35%. Also, we achieved less chemical dosing by 80% compared with other companies' system. Altogether, we managed to cost saving by 25%. In terms of flare gas, again, for energy scarce country like Japan, we find it as such a waste that you're discharging those flare gas into the air and polluting the air at the same time. What we can suggest to utilizing those flare gas, in fact, as the number here shows, 140 billion cubic meter per year. This is an incredible number that we are wasting out of flare gas. Or in terms of CO2 reduction, 1,120 million tons of CO2 you are discharging into the air in this particular region. So what we suggest to treat those flare gas and then produce propane LPG. Or you can also process those flare gas for methane and ethane, and then you utilize it as hydrogen. Those hydrogen, after produced, you can use for either fuel cell vehicle or generating electricity. Therefore, you can use those electricity for produced water treatment and or desalination. So this would create pretty good recyclable management of this flare gas. So these are our capabilities that JFE Engineering has, and our technologies we have already demonstrated, deployed all over the world. However, we do not stop with this point. We also would like to utilize modern IT technologies to create smart operation system for those utilities and those hardware facility and plants. This picture is a little busy, but what I wanted to show you here is that first of all, we need to collect the data of utilities. For example, if it is from the water treatment facility or for waste to energy plant, there is a lot of data supposed to be collected. And we utilize those data collected for optimizing supply and demand balance. By using in order to collect the data, of course, we need a sensor and smart meters. But with those data in real time, you get the information and you understand how your plant situation are and also how your consumer demand size requiring your utility. So therefore, demand and supply optimization, the IT network is necessary. For the utility management, as I just said, but not only integrating data, most important thing is we need to visualize those data among stakeholders. Lots of people in this conference mentioned that you do not really practice that water conservation or energy conservation. But if you can see on your modern IT device or tablet like you have on your hand now, what's the usage of your electricity and water in real time, you would know that perhaps you need to consume less, and therefore you can economize or you can make better resource management. For that, not only for the demand side, but also from the supply side, data is necessary. So what do we do, or what do we try to achieve here, is that from the data coming out of demand side and the supply side, all integrated together, therefore we can make a maximized level of utility supply efficiency And also, of course, in the end, we can reduce the CO2 emission altogether with this environmentally conscious data management. In terms of plant and facility, we also utilize IT technologies. Here at the bottom, you can see several data sets. In fact, those data is asset data or work schedule data, procurement record data, material characteristic data, service level data, or contract record data. Those data actually for facility operators, in fact, they are existing in silo. They are not integrated. But what we suggest through our experience is that we try to integrate those data, and then not only those integrated data, but also we can have real-time data from device and machinery, operation and maintenance, so-called big data. If you're not familiar with what big data is something like a real-time data, keep flowing, coming into your system. So you would be able to analyze if the device or machinery behave anomaly. And by detecting those anomalous behavior, what you can do is that you can predict that there must be some event will happen with a facility, with a plant. Before the big event or incident happened, you can perhaps fix those machinery and fix the plant and facility and well in advance. Therefore, you can minimize the damage of your plant and facility. Because if the event happens for utility side, the water stopped or energy supply stops, the damage to the society is massive. So in order to prevent that, this kind of data combination with asset management are very important, and we call it predictive or preventive operation and maintenance management. So this is a city operation, actually, utilizing IT. Every component, I put it here, those hardware stuff we can provide from JFE Engineering. What we try to do is, as I just explained to you, utilizing those IT network in the system, let those data coming out from every plant and facility communicate each other, therefore we can optimize demand and supply balance. So, we try to provide environmentally oriented service model, not only EPC itself, but for the operation management and the service as well. For this, we try to incorporate IT technology into our business delivery. Since IT can optimize demand and supply balance, also we can integrate town operation and service management, and biogas and biomass production from waste and O&M can be also optimized. The power generation plant's operation can be managed in mass. Also, in terms of water treatment, recycle, we can achieve it with a great economic efficiency. So, this is my last chart. In summary, what I wanted to reiterate here today is that in the modern world, the wastes are no longer regarded wastes. For us, we believe that wastes are resource. So what we should do is that we should evaluate the waste as resource for smarter eco-city. For that, we need to replace conventional business model with advanced environmental technology. We need to improve the data management by utilizing the latest IT technology for facility, plant, and city operation. For that, of course, we need to have real-time data transaction between demand and supply for better utility optimization. In the end, we can realize CO2 reduction and conserve environment, and then we can achieve sustainable development and growth of Middle East countries. Thank you very much for your attention.